Hello there, classmates and faculty. I'm Roshan, and today we're going to be tackling an issue that affects every living being on this planet, climate change. But wait, we'll also dive into chemistry to understand how we can use technology to solve all kinds of problems, particularly those related to chemistry and climate change. This Genius Hour project is a culmination of several projects. Firstly, I created a chemical equation balancer, which we will get into in a second, and after that, I used data science principles to analyze weather data and use it to my advantage to make conjectures about our current climate. So we're going to start off with the chemical equation balancer. The chemical equation balancer, the general premise of it is to analyze a chemical equation as a vector or matrix per se, and use a null space function to find or solve the matrix for the coefficient values or the ratio values for each term in the chemical equation, then multiply it by the lowest common multiple to find integer values for the coefficients. So to start off with it, we're gonna import the necessary libraries. We're gonna use the RE library for regular expressions and SymPy for the matrix operations. And you trust me, these will be our secret weapons in tackling the chemical equations. Next, we have two very important variables, element list and element matrix. These will store the elements and their corresponding counts in the equation. And now we can focus on the first function, which is the compound decipher function. It takes a compound as an index and a side input. And the compound represents a chemical compound in the equation after we split it up. The index keeps track of where we are, and the side tells us if it's a reactant, which would be -1, or a product, which would be +1. Then we split the compound into segments using regular expressions. Inside this function, regular expressions, if a segment starts with a parentheses, that means that there's a multiplier. So we would extract the segment and its multiplier, and then we pass it to the find elements function. In the find elements function, we split the segment into their corresponding counts, and we iterate through these elements and counts, checking if the count is a number or not. If it is, we calculate the total count by multiplying it with the multiplier from the compound decipher function, and finally we add this element to the element matrix using the add to matrix function. The add to matrix function is where the magic happens, so if we check the index matches of the length of element matrix, if it does, we add a new row to the matrix, and if we also add a column for the element if there's a new element in the matrix, and as well to all the other existing rows. If the element's not already in element list, then we can add it and update the corresponding columns in element matrix, and then we can calculate the column index of the element and then update the count. And now that we've deciphered and stored all of the elements and their counts, it's time to move on to the next step, balancing the equation. But before we do that, let's print out element list and the element matrix to see what we've got. So the element list and element matrix will output the actual elements and their corresponding amounts per term in the chemical equation. And then after that, we can use this data to balance the equation. So first we're going to create a matrix using the element matrix list and transpose it. This is where SymPy comes in handy. We can find the null space of the transpose matrix once we've created the matrix, which gives us the solution vector, and we can multiply this vector by the denominator's least common multiple, or the LCM, to make coefficient integers. And then finally, we can format the coefficients and compounds into a balanced chemical equation. We iterate through the reactants and products, and for each compound, we append the coefficient multiplied by the compound itself to the output string. And then we make sure to add a plus sign between the compounds with the same side of the equation. And then we also add an arrow to symbolize or indicate the transition from reactants to products. And then we iterate through the products and append the coefficients multiplied by the product compound to the output string. And then we also include a plus sign between the multiples of products if applicable. I think that should work. And finally, our balanced chemical equation is stored in the output variable. So let's print that out and see what it turns out. And the balanced chemical equation appears right there at the bottom. So there you have it, folks. Our Python script successfully balances the chemical equation. We've gone from deciphering the compounds, calculating the element counts, and finding the solution vector to formatting the coefficients and compounds into a balanced equation. The chemistry is made easy with a touch of programming. So why is understanding and balancing chemical equations relevant in the grand scheme? Well, many of the problems we're facing today, especially those related to climate change, are chemical problems. From reducing CO2 emissions to creating sustainable fuels, a deep understanding of chemistry is critical. Which brings us today to today's second part of our discussion, climate change. It's one of the most pressing issues of our time, affecting everyone on this planet. So we will use some Python programming to analyze and visualize climate change data. Let's see how we can use technology to understand the problem better and potentially develop solutions. Welcome back. Today we're going to be talking about climate change. It's a pretty important topic to discuss, and that's why I believe that it's probably one of the most pressing issues of our time, affecting everyone on this planet. So in this video, we're going to use some Python programming to analyze and visualize climate change data. Sounds exciting, right? So let's jump right in. Alright, so first things first, we're going to have to import the necessary libraries. We're going to use pandas for data wrangling, NumPy for numerical operations, and matplotlib and plotly for data visualization. These libraries will help us make sense of the temperature data and what we'll be working with. So we'll be using a dataset called FOWStat temperature change, which provides statistics on mean surface temperature change by country. This dataset covers temperature changes from 1961 to 2019. We aim to explore this data and answer some key questions about climate change. So now that we have the data, we must pre-process it. We'll rename some columns, filter out unnecessary columns, and merge the data with ISO 3 country codes for better organization. This will help make our analysis and visualization easier later on. So now that we have our data ready, let's dig into some of the questions about climate change. The first question we want to tackle is, from what 10 countries that have suffered from the highest temperature change in the last 10 years? So here's a bar chart showing the top 10 countries with the highest temperature change. As you can see, countries like Russia, Germany, and France are among the most affected. It's important to note that all of these countries are industrialized, highlighting the human activities as an impact on climate change. So now let's flip the question around. We want to discover the 10 countries that have experienced the least temperature change in the last 10 years. So here's a bar chart showing the countries with the lowest temperature change. Surprisingly, India, a developing country with significant industrial activities, is among the countries with the least temperature change. This suggests that industrialization alone may not be the sole factor driving temperature change. So let's calculate the analysis of global moving average and temperature trends. So understanding the long-term trends in a global temperature is crucial for assessing the impact of climate change. One commonly used metric to analyze these trends is the global moving average temperature. This section will delve into the calculation method of the global moving average temperature and discuss the steady upward trajectory over the past 60 years. So, a widely adopted approach involves averaging the annual temperature anomalies over a specific period to calculate the global moving average temperature. Temperature anomalies represent deviations from a reference period's average temperature and usually the pre-industrial era. The moving average smooths out short-term fluctuations and allows us to identify long-term trends more clearly. So, step 1. Data collection and preparation. Collecting accurate and reliable temperature data is vital for collecting the moving average. So, climate scientists typically use data from multiple sources, including ground-based weather stations, satellite measurements, and oceanic observations. Our dataset today comes from the same dataset that we used for those local temperatures and relative temperature changes between countries. Number 2, we're going to use the calculation from the data to calculate the temperature anomalies and the average temperature for a reference period, which would be 1961 to 2019. The average temperature is subtracted from the actual annual temperature, and this calculation helps remove seasonal variations and provides a clearer picture of long-term temperature trends. The reference period is typically chosen to represent a stable climate before a significant anthropogenic influence. Determining the moving average period. The moving average period refers to the number of years which the average is calculated. The longer periods offer a more comprehensive perspective on climate trends, while shorter periods capture more recent fluctuations. Common choices for the moving average period range from 5 to 10 years and occasionally more. Next, we'll be averaging the temperature anomalies. By taking the average of temperature anomalies for each year over the selected moving average period, we obtain the global moving average temperature. This value represents the smoothed and trended temperature data, making it easier to discern long-term climate patterns. Finally, we'll check once we do all of these calculations, we achieve the conclusion that there has been a steady increase in the global moving average temperature. The analysis on the global moving average temperature reveals a consistent upward trend over the past 60 years. By using this approach, scientists have identified the ongoing global warming phenomenon and its potential implication for Earth's climate system. The upward trajectory indicates that on average, the Earth's temperature has been rising steadily, with close to about a degree every 10 years, with a notable year-to-year variation. The steady increase in the global moving average temperature provides a compelling evidence of climate change and aligns with the findings of numerous scientific studies. It underscores the need for urgent action to mitigate greenhouse gas emissions, adapt to climate change, and protect vulnerable ecosystems and communities worldwide. The calculation and analysis of global moving average temperatures offer valuable insights into the long-term climate trends. By smoothing out short-term fluctuations, this approach enables us to identify the steady upward trajectory of global temperatures over the past 60 years. Recognizing the significance of these trends is essential for addressing climate change and implementing effective strategies to ensure a sustainable future for our planet. As you can see, technology helps us understand the extent and impact of climate change, but it can do so much more. The tools and techniques we've discussed today are just a small piece of a much larger puzzle. From developing algorithms to model climate change predictions, designing systems to capture and store carbon dioxide, and using big data to optimize renewable energy use, technology's potential applications in the fight against climate change are enormous. So there you have it. We've explored some key chemistry and climate change issues using Python and data analysis. The goal here is to understand the problems and inspire you to think about how you can use coding skills to help solve these problems. We all share this planet, and we all must use our knowledge, skills, and passion to make a difference. Thanks for watching.